So may I ask you now, how many of you have started reading the potential flow, or have gone through the video lectures? How many video lectures you have gone through? Is it zero like the problem sheet, or you have started reading and also going through the video lectures? What is your status?
Sir, I started going through the video lectures.
Sir, I have started the sir boundary layer theorem. ওই ইয়ের পরে viscous flow পরে স্যার।
Why?
স্যার অ্যাকচুয়ালি আমি
you have, I mean,
স্যার আমি ওই মডিউলটা ফলো করার চেষ্টা করছিলাম, তো আর কি মানে আমাদের সিলেবাস মডিউল অনুযায়ী ওই তার ডিসকাস ফ্লোর পরেরটাই ছিল বাউন্ডারি লেয়ার থিওরেম, তো আমি সেটাই আর কি করছিলাম।
But you are doing it in a parallel mode. I don't have any objection into that, but we are going in a different manner, that I can say, because I think the materials that we have uploaded in your classroom are on this topic, potential flow, isn't it?
Yes, sir.
So whatever you are following actually, that I think is based on a particular textbook or some other materials you are following. I am nobody to object that, but if you want to remain with the pace and with the approach that we are following in the class, I think you have to adhere to whatever actually is being given as the material and whatever discussed. Because in this class, I am not going to discuss anything on boundary layer flow. That will be on different schedule altogether once we complete this potential flow, because this is the manner we actually approach to this fluid mechanics too. We start with viscous incompressible flow, and then we left the viscosity part and we enter into the potential flow or ideal flow. In many textbooks, the approach is a little bit different, maybe, where you may find the potential flow to be treated later. Before that, maybe boundary layer flow has been discussed, but we approach in this manner so that, I mean, the reason is you have to understand the potential flow theory, so that while again we go into the boundary layer flow, you can differentiate between these two. The boundary, what it actually means. So, and also basically the relevance of learning potential flow can be, I think, better understood when you have the knowledge of this ideal flow treatment on different flow situations. And then when you enter into the real world, just a minute. So what I was saying, if you have the knowledge of the treatment of different flow situations that we will go through when learning this potential flow theory, and then when you enter into the real world situation, which is typically the case where you have to consider the existence of this hypothetical layer, where inside which the presence of viscosity is significant, and then what actually the changes that is going to take place in case of flow about different bodies. So from ideal situation to real situation, that is the typical approach we will be taking here, and we normally take that route. Okay, so yeah, so basically let me get some other opinion from other students, one or two more, so that we can have a discussion in that direction. So অরণ্য, I think আমার মনে হয় যে তুমি একটু ক্লাসের সাথে থাকলে ভালো হয়।
হ্যাঁ স্যার, আমি নেক্সট এ থেকে ওই পোটেনশিয়াল ফ্লো স্টার্ট করবো স্যার। মানে আমি একটু জানতাম না যে এটা পরে, মানে আপনি এই পোটেনশিয়াল ফ্লো থেকে স্টার্ট করবেন, তো আর কি।
না অলরেডি আই থিঙ্ক আমার মনে হয় তো দেওয়াই আছে না, মেটেরিয়াল ক্লাস রুমের মেটেরিয়াল গুলো সিকোয়েন্সটাকে ফলো করার চেষ্টা করবে, কারণ নির্মল স্যার অলরেডি মনে হয় দেখবে যে সমস্ত মেটেরিয়াল পোটেনশিয়াল ফ্লো তুলে দিয়েছে। সো ইট ইজ অবভিয়াস যে নেক্সট আমাদের, এবং আমি সম্ভবত বলেও ছিলাম আগের ক্লাসে, আবার মনে পড়ছে না, আই থিঙ্ক আমি বলেছিলাম যে নেক্সট আমরা পোটেনশিয়াল ফ্লো শুরু করবো ডিসকাশন নেক্সট উইক থেকে। তো এনিওয়ে, তো ওইটা একটুখানি ফলো করলে তাহলে, আমি বারবারই যেটা বলেছি প্রথম ক্লাসে, আই হ্যাভ সেড দ্যাট ফ্রম দ্য ভেরি বিগিনিং, that this one should not expect to be typical way of delivering the contents, which is already there in your video lecture, video material. Okay, so here, until and unless you have some at least level 1 knowledge of the content, okay, so that, I mean, in the last class we have done that discussion, which I think was rather the way we should go in this meet. Okay, so that is the thing. So any other opinion or any other feedback you want to give? How much actually you have learned, you have gone through on this particular topic, potential flow? Anybody wants to say something? We have to
The
yes,
source and sink flow में I am
yeah, Satyam.
source and sink flow. So source and sink flow.
So up to source and sink flow you have gone through.
Yes sir, yes sir.
But what about, yeah, that's good, but what about the others? I mean, everybody has reached to that level, or just they have started, or they have done nothing? What is the answer? I think the third one is going to be 90%. Is it so?
Sir, I was working on the loose end of FM1 course. Some part were left, I was covering that.
Yeah, pardon?
So I was covering some of my loose points in FM1 course.
Okay, so you are covering from some other course, other
The previous semester's course, sir.
Sir, I have done the similarity past part, so I have reached towards the flow nets, sir. I am doing now the flow nets.
Okay.
I just started with the flow nets, and the similarity part I have completed, sir, with pi theorem and.
Similarity part means that velocity, potential, stream function part. This part you are saying.
Yes, sir. Yes, sir. This part I have completed.
Okay. Yeah, but the previous speaker, who was that? Setsu.
Yes, sir.
Setsu Dev, na? Setsu, you were covering previous semester. Come again. I don't
Some
get.
portions, sir. Some portions were left from my end, sir. I was not able to cover in time. So in order to understand it better, I was covering that.
Okay.
I'll do that. I'll complete that in 1 or 2 days.
No, which part actually you are covering? You are actually covering which?
Sir, I was covering some dynamics portion like that, Q and those portions. And the last slide, some portion was this.
With dynamics part.
Yes, sir.
Euler equation, Bernoulli's equations. Those part actually you are left with to have
Yes, sir.
transparent understanding.
Yes, sir.
Okay. So, but that you have to catch up. I mean, because this lag needs to be compensated. Otherwise, you will remain in a lag situation.
So I'll cover that within 1 or 2 days, sir.
Yeah, because otherwise, if we will be going in a particular pace, and if always you remain in that manner, you cannot grasp the present discussion. Okay.
Okay, sir.
Sir, I'm a little slow because, sir, in the second sem, my mathematics knowledge was not the partial differential equation solving. So that's why I said to grasp the mathematical concept first, I am little late, sir. But I will cover it up between 2 and 3 days.
Okay. So what I think we should do. I mean, let us fix a particular point. Okay, up to which you should go through before the next discussion start. Okay, so let us set some target. Otherwise, I think it remains very open-ended. So in that situation, it would be very difficult to cover. So let us say, I mean, today I will be just giving you a brief introduction of this potential flow and something which probably you have done in your fluid mechanics 1. Let me see. And but in the next meet, we should cover up to say the basic flow patterns like the source flow, sink, then this circulation, vorticity, and also your vortex flow. I mean, free vortex, force vortex.
Superimposed flow.
Yes.
Superimposed flow, sir.
The superimposition part, at least, I mean, we can done it in another day. Okay, but in the next class, I think if you can cover, I mean, if you can cover it properly, we can even start this. I mean, we can start the discussion up to superimposition of 1 or 2 cases, like the uniform flow plus the source flow. What will happen? Because I mean. So let me go. So that actually will be the target for the next day's discussion. So keep a note on that. Up to at least all the basic types of basic patterns of flow. Up to that, we should have either reading the material plus observing the video lecture, and whatever clarification or whatever difficulty you find and whatever clarification you need, that I think you should address, I mean, first, so that I can have the orientation, means in which in direction I should start discussing, right? And that also, I think, will help you to basically to revise whatever you have learned and whatever shortcoming were there in the process of learning. This is number 1. So that should be noted. So in each and every meet, during the end, actually, we will set the next meet target. Means what will be the topic of discussion, and that means I mean that it is implicit. It should be implicit that the moment I say that this will be the topic of discussion next day, that means that you should go through the materials, reading as well as video. So this is number 1. Number 2 is that regarding the problem set. Actually, I thought to have a session next week, 1 hour session at least on the problem set. But the problem that I find, I think it is not possible. It is not going to be possible next week. Okay. So next to next week, typically you set the target like that. Next to next week, you should have the completion of this discussion on the problem sheet. Okay, and please do not think that it would be like starting from problem 1 to problem 14. Typically, I think 14 number of problems or 15, whatever the number of problems are there. It is not going to be one-to-one, discussion on each and every problem. You should again give me the feedback that what are the problems you are facing difficulty to solve. Okay. There are certain problems which are very straightforward, and I don't think those need any kind of discussion whatsoever. But there could be some problems that they require some kind of discussion. Let us identify those. All right. So this is point number 2. Okay. So with that, so let me have the basic introduction to this potential flow, and this potential flow is also known as ideal flow. I need to join once again. Okay. Okay. So this potential flow is also known as ideal fluid flow. That means it is not the real situation of the flow we are going to deal with. And this idealization means the fluid is non-viscous, or it is also called as inviscid. Right. And the fluid is incompressible. And the third one is the flow is
Irrotational.
irrotational, correct. Okay. So these are the 3 I's actually: inviscid, incompressible, and irrotational. The 3 assumptions of flow that makes it ideal. That means this density is not changing, there is no viscosity, and fluid is not rotating. The flow is not, there is no angular velocity, or there is no vorticity.
স্যার ইরোটেশনাল কেন ধরা হয়?
Irrotational dhora because typically this is a kind of ideal fluid flow is dealt as a 2D planar flow. Okay, also that means you have say if you have a conduit like this where fluid flow is occurring. So this is the axis fluid flow is occurring, and you can have okay, so these 2 axes. So along these axes, if I say this as z axis, along these axes nothing is changing. So that if you make a slice, at this particular point as well as at this particular point. All right. If I call it this x and this is y. So at this particular point also we can have this flow description which remains same. Okay.
আচ্ছা স্যার, তাহলে মানে যদি একটা সার্কুলার টিউব হয়, মানে টিউবটাতে যদি একটা কার্ভেচার থাকে, তো ওটাকে আমরা ইরোটেশনাল ধরতে পারবো না, তাই তো? কারণ
No,
আমাদের
no,
ক্রস সেকশন তো বেঁকে যাচ্ছে।
we need to understand what exactly. I mean, a circular motion can be irrotational. Okay, can be rotational. We will see that circular motion doesn't necessarily means it is always going to be a rotational. Rotational flow. It could be rotational, but the motion could be circular. For example, if you look into a situation, perhaps you can also try in your home also. If, all of us are having sink in your bathroom or in your typically the sink that we are having in our kitchen. So if you just block the outlet of the sink by some means, some sinks are having covers. So if you cover it and you fill the sink with water, okay, and you place some small, say, pieces of some objects which can float. Okay, maybe some pieces of paper, small pieces of paper. মানে একটু ছোট ছোট করে কেটে যদি
স্যার ফ্রি ভর্টেক্স ফ্লোটাই তো ইরোটেশনাল হয়।
হ্যাঁ,
ফ্রি ভর্টেক্স ফ্লোটাই তো ইরোটেশনাল হয়।
free vortex flow is irrotational. Yeah. So what is free vortex flow? And you are actually placing another term to define irrotational flow. So what is free vortex? That we need to understand. So physically, the thing is that you, on this simple experiment, you can identify what is free vortex and what is force vortex, or what is actually rotational and what is rotational flow. So after doing that, if you now suddenly open the outlet, you will find a particular phenomena that occurs at the center. I mean, if you're seeing typically the things are having its outlet at the center position, so there actually you will find some kind of a whirl motion, right? So and there's a kind of a void you can identify at the center, and fluids are like rushing towards the center and having a rotation. So how you can identify that? You can, by observing those objects which are floating, you will find that towards the periphery, towards the outer end, actually, the objects are having a circular motion, but those objects are not rotating about their own axis. But as they are going, it's a kind of a spiral effect. They are having their trajectory like a circular trajectory, but simultaneously they are also being attracted towards the center. And as they move towards the center, you will find that suddenly they have started rotating about their own axis. So if we consider that object as a fluid element, because as I said, the fluid particles which are attached with the object by no slip condition, those fluid particles are going to have the same motion. So typically the fluid element also at the peripheral part, they are having a rotation, they are having a circular trajectory, but those elements are not rotating about their own axis. If the elements are not rotating about their own axis, we call it as irrotational. But it can move in a circular trajectory. So typically towards the center, those objects are having rotation about their own axis. They are having a circular trajectory as well as rotation. Typically, the earth motion you can consider, if the earth is not rotating about its own axis, but it is having a revolution about the sun, so that will be an irrotational motion of earth about the sun. All right. So that is another way you can have some kind of analogy. of irrotational
স্যার
flow and
একটা কোশ্চেন থেকে গেল, বলছি যদি মানে ধরুন একটা সার্কুলার টিউব আছে, এবার ওখানে আমরা একটা কিউবার্ড ধরলাম ফ্লুইডের, এবার সেটা মানে এবার যদি ওই কিউবারটার উপর আমরা চেজেলস থিওরেম অ্যাপ্লাই করি, মানে ওই একটা ট্রান্সলেশন প্লাস রোটেশন হচ্ছে, তো
Hmm.
ওটা তো মানে ট্রান্সলেট তো করছে, কিন্তু ওরিয়েন্টেশনটা তো মানে পাল্টাচ্ছে আর কি কিউবারটার। এবার ভেতরে যে ওই কিউবারটার ভেতরে মানে যে ফ্লুইডটা আগে ছিল সেই ফ্লুইডটাই আছে, তো তাহলে তো মানে ওটা ঠিক রোটেট করছে না।
It may so happen, তুমি যেটা বলছো, typically it may so happen a fluid element may undergo translation, rotation, as well as deformation. All possible. Okay. Typically, আমার এখানে irrotational বলার মানেটা হচ্ছে যে there is not going to be any kind of angular deformation possible. Okay. Now, in general, as you have said, I mean, in my first this Navier-Stokes note, probably, if you look into that, and this situation was there. This typically the angular deformation part. If you look into this, as you are saying, this is basically the element XY. I mean, in a 2D planar manner, this has been treated. So here you can have a linear motion. So U and V both are function of X and Y. So basically, with respect to A, B point is moving faster. It is having U plus del X, delta X as the velocity. Likewise, U is also having U plus del U, del Y, delta Y. So you can have this kind of situation after some time delta T, as it is shown here. So which necessarily, depicts that this element ABCD, which was originally in this shape, now becomes after some time delta T, it becomes like this in the dashed form, A, B double prime, C prime, and D prime. So here, what do you say? About the motion, whether it is purely translation, purely rotation, or combination of translation, because definitely it is being translated from this point, from this location in space to the new location here. So there has been a linear translation, as well as we can say that there is a rotation in combination with a deformation. Do you agree with that? And mathematically, we have treated this thing also to get the expression of this strain rate, angular deformation rate, which can also, which when becomes equals to zero, you will be having irrotational flow. So that is typically being written here also. Yeah. So the angular deformation rate or strain rate, as you can see, is found to be del V del X. There is one component. That is this alpha and beta we have shown here. This is d alpha and d beta. So this is my d alpha in this direction, and this is d beta. Both can be expressed in terms of the respective velocity gradient, and mathematically it can be shown that this d alpha dt, that is the rate of change of angular strain, is del v del x, and similarly this d beta dt will be del u del y. So the total deformation will be additive. So you need to add both so that you get the this gamma dot xy. So xy is the plane. Okay, so this is the addition. If you add it, you get the total deformation. Okay. So that is basically the deformation which gives rise to my strain relationship, right? But if you want to get the rotation, right? Here, once again, I refer to this figure. If I consider anti-clockwise positive, so that I can say this AB side of the element ABCD is having a rotation in the anti-clockwise direction as it is shown. Okay, and that is again something del V del X, right? The rate of change of the orientation, that is d alpha dt. The other side, AD, has been rotated in clockwise direction as it is shown here. So that will be negative, isn't it? If I consider the direction of rotation positive in anti-clockwise direction. So d beta dt will be minus del u del x. So that I can write the net rotation of this element will be del v del x minus del u del y, isn't it? That is what is being typically done here. This omega z, that means this rotation is actually about the axis normal to the plane, okay? And it is actually written in average manner, half of del v del x minus del u del y, right? So later actually you can also find some kind of revisit of that element here. So this is the elementary rectangle which is having this thing. So I mean here the approach was a little different from evaluating the circulation. We can obtain the condition of irrotationality or condition of rotation, whatever you say. If this term is equal to 0, then the situation is irrotational, but this equal to 0 does not mean that the fluid element is going to be undeformed. It will be having angular deformation, right? Because the angle of deformation in both the direction will be same. So it will be simply added. So it will be just twice of either del v del x or twice of del u del y if del v del x is equal to del u del y. Okay. So this is the physical significance of what is meant by rotational flow and irrotational flow, and how that can, and also along with that the deformation part which gives rise to this shear stress, and that from the point of view of dynamics or the cause which basically results to either pure rotation or pure deformation, pure angular deformation or pure rotation, or in between that means combination of both rotation as well as deformation. Because the other situation is that it will be a pure rotation when you are having del v del x is equal to minus del u del y. So these two will be, then the net will be added up. But there won't be, in that case, no deformation. So as a whole, the entire element will be rotating. Okay. Typically, you can understand that when you are having a straight parallel flow, there you are having actually deformation, right? Straight parallel flow means deformation is occurring, isn't it? But there is no rotation. Can you understand this? Or you have not understood anything?
Yes, sir.
বোঝা গেছে? যখন আমরা প্যারালাল ফ্লো এর কথা বলি তখন কিন্তু বেসিক্যালি কোনো রোটেশন হচ্ছে না, কিন্তু ডিফর্মেশন হচ্ছে, because you are having del u del y term. Okay. So you are having that as a pure deformation, but there won't be any rotation. So that is one very important aspect. I mean, to look into the situation of flow. Okay. So in case of for idealization, we consider this flow to be irrotational. Another perspective of looking into this is that you are having from the perspective of the velocity potential of the flow. We will look into that a little bit later part of our discussion. But before that, I mean, the genesis of this potential flow or ideal flow was much older than your this boundary layer flow. Typically, 18th century was the time where people used to analyze the hydraulic situation using mathematical modeling, and that was purely from the mathematical aspects without looking into the physical situation. Okay, and considering no friction, that is no viscosity and no boundary layer. Okay, so that was the initial approach of dealing with fluid mechanics from pure mathematical point of view, and with certain consideration, as already we have seen. In addition to those three, the flow is going to be steady as well. Okay. But I mean, one may ask then, sir, what is the relevance of studying the same age-old ideal situation flow or ideal fluid flow when there is no such situation in reality? The answer is yes and no, both. Yes, if you consider the ideal flow situation, yes, in reality there is no such situation. I mean, that is perfectly you can consider to be ideal. But there are possibilities as it is written. For example, if you consider viscosity to be equals to 0, it is an idealization. But as if you can recall our earlier discussion, where there could in the very introduction part, I have said that if you move away from the boundary, that means the interface between fluid and solid, if you move far away, there could be a region beyond which the effect of viscosity can be reasonably assumed to be negligible. So that point onwards, you may have a situation close to no viscous situation. And also, there could be the situation where the velocity of flow, if it is not to that high level, typically in case of gas also, I mean, in case of air or gas as a medium, even air or gas is highly compressible. It can be treated as incompressible if you are having the velocity of flow to be much, much less than the local sonic velocity. Okay, so that you are having the change in pressure to be almost instantaneously felt. So that will be a situation where you can think the flow to be incompressible. And the irrotational part also we have discussed. So there could be a situation in reality where these assumptions are still now relevant. I mean, again, it is not exactly the situation that one can expect. But this particular study, from the highly mathematical perspective, you will see that the entire treatment of potential flow lies on mathematical base, more mathematical than physical analogy. What actually is being done when this gives us insight about certain flow situation, which later on, after the introduction of this boundary layer flow, that means this interaction with fluid and solid, gives us certain modification in the flow structure, in the flow domain. But by and large, from potential flow, we can get the idea of different aspects of fluid dynamics. Okay, typically the lift, the drag force, which for an ideal flow situation is unexpected, because this treatment of mathematics, as you can see, those who have already gone through it, are based on purely kinematics, because it actually describes the motion only. There is no such treatment of force, etc. at the very beginning of this concept of different types of basic flow pattern. It is basically the description of flow pattern, minded, no matter what is the reason of this flow pattern. From those description, and after that, when those are being combined, those gives us some insight about what should be the shape of a body, which will be going to be an efficient body shape, so that you can have minimum loss. So this is the significance, one of the significance of studying this potential flow or ideal flow. And also, even if this is a ideal flow situation, you will see that you can have some idea about some kind of force due to this pressure variation. Okay, in the flow domain, and that gives us some kind of insight about why we get a lift when we rotate a body, we throw a body with a rotation, typically in either in terms of your cricket, the spinning of a ball along with its swing, or in terms of football, if you have the free kicks, if you have the experience of looking at free kicks. In our time, it was Beckham, famous for Bend It Like Beckham movie. It is a kind of a banana free kick where you are having a swerving trajectory of the ball along with its spin. So that means there is a definite force acting due to this particular motion, along with the ambient condition, that gives a deflection of the body. Your ideal fluid flow treatment may give you some kind of knowledge about that to start with. So that is, we can say, the relevance of studying potential flow or ideal flow still now. And as it is in terms of timeline earlier than the more realistic boundary layer flow, we normally go through this potential flow or ideal flow treatment first, and then we move on to the boundary layer flow. So that is, that doesn't mean it is the universal way. In different textbook, you can see the treatments are being made in different sequence, okay, as per the convenience of the author. Okay, so with this basic introduction, I think keeping these in mind, you start going through those things, those fundamentals of this ideal flow treatment, and up to this basic flow patterns, at least you should go through, so that in our next class, next meeting, we can have a very quick summarization of what is there in the basic flow patterns, and we can have some discussion on the later part. Of course, in this up to basic flow pattern, if you are going to have any kind of query, typically the one that is being raised here, which is very interesting question that is being raised. I don't know whether you are satisfied, he is satisfied or not. Who has raised that question? The rotational flow, I forgot it. কে করেছিল এটা ওই টিউবের মধ্যে দিয়ে একটা প্রশ্নটা? Anyway, so that was a very so that kind of discussion we can expect to have, but again, to make it more participatory in nature, others should also have the same level of at least kind of same kind of energy level or same kind of knowledge level should the others have. Otherwise, it will be one-to-one dialogue only, and the rest may not find interesting. So, which I think I can see in the number of participants right now, which is falling. So that is the unfortunate part. I mean, you prefer to have this kind of live interaction, but after few days, the participation goes on falling. Okay. So that is also not desired, that I can say. But anyway, I mean, those who are interested, at least they are present. So that is, we have to live with it. Because all of you are grown up, so I cannot force you to remain present in the class or in the meet. Those who are interested, because there is no such penal action also I can take, and it should not be taken like that, because it is an adult world. You are a college student now, you are not a school student, so that, I mean, that I can send letters to your guardians and I call the guardians, something like that. Okay, so it is up to you. Typically, I mean, previously we had some kind of incentive to remain present in the class by awarding the marks. So 5 marks were there in our time. Okay, so, but now it is no longer there. So no marks is there, no incentive is there as such in terms of marks. And also there is no such kind of disqualification to appear in the examination because of low attendance. Okay, so that is also not, that is there in terms of paper, I mean, that exists, but that is not being practiced, that you can say. And the third one is, now we are having this typical situation. So in online mode, attendance is not going to be any kind of criteria for any evaluation. Okay, so I also believe in that. So I'm not forcing anybody to come and join in this meeting, but it is your desire, which we find from your survey. Okay, so it is your responsibility to keep it in a good shape by participating. Okay, so I think today we can end our meeting here, and as not all of you are having the same kind of start, maybe only very few that I find. So I have just introduced you with this ideal flow, what are the assumptions and why those are being taken, and what are the relevance with real world by learning this. So with that understanding, I think you should start going through the material up to basic flow at least. Maybe more than that if you want, no issue. But those who will come next day, at least they should go through the video lecture and the content. I mean the written content. And also you should start solving so that next week we can fix a date for the doubt clearing session on the problems. So now if you're having any kind of query, you may ask, otherwise we can end the meet. Okay. So any query or any questions from your end? কিছু যদি তোমাদের বলার থাকে বলতে পারো, আর না হলে আমরা তাহলে আজকে অলরেডি প্রায় 2:02 হলো, তাহলে আজকে মিটটা শেষ করি। আমরা নেক্সট আচ্ছা কালকে যেটা হলো না সেটা একটা সময় করে নিতে হবে, এটা এই শনিবার দেখে নিচ্ছি যদি সম্ভব হয় তাহলে এই শনিবার, আদারওয়াইজ কোনো একটা দিন আমাদের এটাকে করে নিয়ে কম্পেনসেট করে দেওয়া যাবে। ঠিক আছে, ওকে, তাহলে thank you. So we are ending the meet now.
Thank you, sir.
Thank you.